Current, electricity. First topic, electric current. Will indicate with I, electric current, flow of charge per unit second. In shortcut, net charge flowing across a cross-sectional area, cross-section of the conductor in 1 second. That means total charge per unit second. Flow of charge per unit second is called electric current. This is the fundamental quantity. Dimensional formula I. Otherwise, based on SI unit ampere A. I or A we will use as a dimensional formula. Charge is equals to I into T. Here, using this formula only, we will write dimensional formula of charge I into T. Here, 1 ampere. How to will define 1 ampere? 1 ampere is equals to 1 coulomb per 1 second. That means whenever current is flowing in a conductor, that total charge is 1 coulomb flowing in a conductor in 1 second. This is the definition. That means the current flowing through a conductor is said to be 1 ampere when 1 coulomb of charge passes through it in 1 second. That means in shortcut, 1 ampere is equals to 1 coulomb per 1 second. Next, current density. Current density here based on formula, remember it properly. J. Current density J is current per unit area. Current per unit area. That means I is equals to dq by dt. dq by dt. Here, the amount of charge flowing per unit cross-sectional area. Using this formula, total charge flowing in per unit area per second is called current density. Otherwise, electric current per unit area also current density. Here, current density, SI units of current density is ampere per, here cross-sectional area means meter square. Ohm's law. At constant temperature, here potential is directly proportional to the electric current. Potential is directly proportional to the electric current. Here, whenever current is passing through the conductor, in that potential difference between the two ends is directly proportional to the electric current. After removing this proportional symbol, one constant we are taking, that is R. R is the resistance of the conductor. Resistance is equals to V by I. Resistance is equals to ratio of electric potential by to electric current. Here, this resistance SI unit is ohm. This resistance symbol is like that we will write. Now, whenever following this Ohm's law, that means conductors which obeys Ohm's law, that materials are called ohmic or linear conductors. Examples, metals. Graph between electric potential. V means electric potential, I is electric current, like that. And y-axis I, x-axis V. This graph passing through the origin, straight line passing through the origin, like that. Straight line we will get whenever we will draw graph with I and V. Next, non-ohmic conductors. Based on this Ohm's law, suppose Ohm's law it is following, that conductors are ohmic conductors. Ohm's law not following, that conductors are non-ohmic conductors. Examples, carbon compounds and diodes. Graph between V and I non-ohmic conductors, it is a curve. Whenever we will draw non-ohmic conductors using these potential and electric current, we will get curve. Next, resistance. Resistance means how to we will define with capital R. Resistance is opposing the flow of charge. Opposing the flow of charge is known as resistance. This is the property of virtue of which a conductor opposes the flow of charge in it is known as resistance. One more formula already told, ratio of potential to electric current. SI unit of resistance is ohm. Next, symbol also we will use like that, ohm symbol we will use. Here 1 ohm. How to will define ohm? Ohm is equals, that means resistance is equals to V by I. Whenever we are taking potential difference 1 volt and electric current is 1 ampere at that time, that is called 1 ohm. That means resistance of a conductor through which a current of 1 ampere flows when the potential difference between its ends is 1 volt. That means here 1 ohm, whenever we will call 1 ohm, this electric potential is 1 volt, electric current is 1 ampere. R is equals to V by I. V value 1 volt, I value 1 ampere, that is called 1 ohm. Dimensional formula of resistance. Here R is equals to potential by current. Potential, how to will write? Work done per unit charge. Work done, bringing a charge, work done to bringing a charge from infinity to a point on the electric field, that is called electric potential, W by Q. Now W means work. Work dimensional formula, work formula we have to write, that is work is force into displacement. Force is equals to M into A. Same, it will repeat again. M into A. M, capital M. A, acceleration is L by T square. S, L. Next, charge dimensional formula IT. Next, electric current I only. Now how to will write? M power 1 L square. This T square into T is T cube. It will go up, T to the power of minus 3. I square means I to the power of minus 2. This is the dimensional formula of resistance. Next, conductance. Reciprocal of resistance. Reciprocal of resistance is called conductance. G is equals to 1 by R. Now SI unit of conductance is Siemens. Otherwise, based on this formula, 1 by ohm. 1 by ohm is conductance. Dimensional formula, this reverse. We will take resistance reciprocal. Reverse M power minus 1, L power minus 2, T power plus 3, T power plus 2 we will write. Conductance dimensional formula. Next, depends on resistance. Resistance of a conductor is directly proportional to the length and inversely proportional to the area of cross section. That means this R is directly proportional to L and inversely proportional to the cross sectional area. This length and cross sectional area. After removing this symbol, we are getting one constant. This is the rho. Rho or S. This is called resistivity. Resistivity or specific resistance. Specific resistance is equals to cross multiply RA by L. Here cross sectional area, This is cross sectional area means whenever we are cutting pipe, that is circle only, na area of a circle we will write instead of a pi r square, where r is the radius of the cross sectional area. Specific resistance, otherwise resistivity r rho r s, any one symbol we will use, that value ra into ra by L. This is R is equals to rho L by A. Here we will multiply and divide with L, rho into L square by AL. Area into any side, it is giving volume. Resistance is equals to rho into L square by volume. One more formula we will write like that. Resistance does not depend on the electric current and voltage potential difference. Now this specific resistance and otherwise resistivity, how to we will define based on formula. Here rho is equals to Ra by L. That means here resistance of a conductor, this resistance of a conductor per unit length and unit cross sectional area. Ra by L only, na, resistance of a conductor of unit length, resistance of a conductor of unit length per unit area. That means length value L value 1, A value 1, at that time R is equals to rho. This resistance only is called specific resistance, otherwise resistivity. SI unit of resistivity, ohm meter. Next, conductivity. Conductivity means here reciprocal of resistivity, reciprocal of resistivity. Next, SI unit of conductivity, Siemens per meter, Siemens per meter. Next, drift velocity. Drift velocity, here whenever electric field is there, at that time here total charge is moving towards to the positive terminal. That means here due to electric field, velocity is acquired by the free electron inside the metal. That is called drift velocity. The average velocity acquired by free electrons inside a metal by the application of electric field is known as drift velocity. Thank you. One more small topic, mobility. Mobility of a charge carrier is defined as the average drift velocity resulting from the application of unit electric field strength. Mobility mu is Vd per unit electric field. That means drift velocity per unit electric field is called mobility. Now remember this, electric current I is equals to Q by T. Current density J is equals to I by A. Resistance R is equals to V by I. Conductance G is equals to 1 by R. Resistivity, otherwise specific resistance rho is equals to Ra by L. Conductivity is equals to 1 by rho. Conductivity is sigma. Drift velocity Vd is equals to I by A into Ne. Mobility Vd by E. Thank you.